Today, for the first time ever on the Horsepower Monster, we're experimenting with the old throttle in a bottle. We're going to see if we can build a streetable Ford small block with Prestige Motorsports and bust off 1,000 horsepower thanks to a healthy shot of nitrous. But we're going to go about it in a very different way than many of you old school builders are used to. If you're new to this channel, we're all about cool engine builds and building cars and trucks that make a ton of power. So if you haven't already, please like and subscribe. And with that out of the way, back to the build. This time around, we've got for you a Ford small block build that our friends at Prestige Motorsports are working on for another of Holley's really cool engine giveaway contests. The goal the guys at Holley gave them was to build a Ford that can make 1,000 horsepower on nitrous. But after that, they pretty much left it up to the guys at Prestige to decide how they wanted to achieve it. Prestige Motorsports is no stranger to 1,000 plus horsepower builds, and they know how to make them work in the real world. Not every block can handle that kind of power without splitting right down the middle. So to avoid that kind of catastrophe, Prestige chose a Man of War cast iron block from World Products, and then they put it through their full machining process. The Man of War is designed and cast specifically for big power applications just like this. Plus, it's recently been redesigned and updated with several really nice improvements. Namely, the material used in the casting is high-strength 40,000 PSI rated cast iron, which is much stronger than anything the OEMs use. Besides the stronger material, the main webbing is now beefier, especially the center 3 mains that see the greatest stress. There, the webbing is now 30 thousandths thicker. Interestingly, World's engineers said that they also made the block stronger by swapping out the OEM half-inch main bolts for smaller 7/16 inch ARP bolts and studs. They say that the fasteners never fail anyway, and by decreasing the diameter 1/16 of an inch, that just increases the overall amount of meat surrounding each main stud. There's also 6 head bolts per cylinder for greater clamping load, and the galleries in the priority main oiling system have been enlarged for better flow. Also, the cylinder bores have been extended downward, which helps support the piston skirts in stroker applications. But you may have to notch them a bit to clear the big end of the rods like you see here. Overall, the Man of War block is a little bit heavier than other Windsor style blocks, but for high horsepower builds, it's really tough to beat. Going into the block is a forged eagle crank that's already been internally balanced. The crank has a 4-inch stroke, so to squeeze it into the block's 9.5 inch deck height, it's matched up with a set of Eagle's 6.25 inch long connecting rods. These H-beam rods are forged from 4340 steel and designed to withstand tons of compression forces from combustion without twisting. They've also been upfitted with ARP 2000 rod bolts for extra strength. Finishing up the rotating assembly are 8 pistons from DSS Racing. They were chosen because they have a good blend of great strength and light weight. They measure in at 4 inches 125 thousandths in diameter, so combined with the 4-inch stroke, that will give the engine a final displacement of 427 cubic inches. In order to fit those long 6-inch 250 thousandths rods in with a relatively short 9.5 inch deck, the pistons have a short 1-inch 280 thousandths compression height. And to help keep the compression manageable with the extra stroke, the dish, or more accurately the reverse dome, is sized at 22 cc's. The ring set here is also a little bit unique. They are sized at 1.2 millimeters for the top ring, 1.5 for the second ring, and 3 millimeters for the oil ring. Cody McCleary drops the crank into place. Then he installs the one-piece rear main seal and the billet steel 4-bolt main caps. Here's a shot with the rotating assembly complete. The oil pump you see is a Melling high volume unit, and the pickup matches up with the Canton Oil Pan we'll be installing later. One issue we did run into is the man of war block's rear main cap did have some fitment issues with the Canton Pan. The Canton Pan is fully fabricated and a little bit different where it matches up at the back of the engine. Anyhow, this was fixed easily enough by grinding the corners of the cap back, as you can see here. We'll get back to the pan in a second. First, engine assembler Larry Broker installs the camshaft. The valve timing will be managed by a solid roller from Comp Cams. It's ground with 260 degrees of duration for the intake valves at 50 thousandths tappet lift and 274 degrees for the exhaust. Both the intake centerline and the lobe separation angle are set at 114 degrees, and the lobe lift is 431 thousandths for the intakes and 430 for the exhaust. Then the cam is timed up to the crankshaft using a double roll timing set from Liberty. With the aluminum front cover on, the Canton Oil Pan can finally be installed. This is one of Canton's road race oil pans that's fully fabricated with a rear sump and a 6-quart capacity. Up front, Broker installs a damper from Innovators West. Prestige likes these dampers because they're SFI rated, so they're welcome on any track, and the aluminum shell helps cut rotating weight versus steel. To go with the Comp Cam, Prestige is using a set of solid roller lifters from BAM. Broker has already painted the ID of the lifter boards with the engine assembly lube, so everything slides in nice and smooth. For the cylinder heads, Prestige went with a pair of AFR's Renegade 20-degree heads for the small block Ford. Hitting that target 1,000 horsepower will create a ton of heat in the combustion chambers, and all those superheated exhaust gases are going to have to flow right around the exhaust valves. So the stainless steel exhausts are swapped out for a set of AFR's Inconel exhaust valve, because that material is more resistant to insane heat levels. The valves, by the way, are sized at 2 inches 100 thousandths for the intakes and 1 inch 600 for the exhausts. Both have 8mm stems. The heads are fully CNC machined, including the 58cc combustion chambers, which you can see here. The valve springs are a nested set with approximately 220 pounds of pressure on the seat. They also have the ability to handle 710 thousandths of an inch of valve lift before going into coil bind, and that's going to be necessary because we'll be running nearly that much on this engine. Broker has already installed the Cometic multi-layer steel head gaskets and the ARP head studs in the block in preparation for the cylinder heads. So a thin layer of silicone on both sides of the gasket's ears will help prevent oil seepage later on near the top of the heads. Here, you can get a better view of AFR's CNC cut intake ports. If you're going to make big power, then you've got to be able to move a lot of air and fuel, and these 220cc intake ports should be able to do exactly that. The exhaust ports, meanwhile, are raised a bit to help improve flow and are sized at 80 cc's each. I know we already talked about the valve springs, but here's a better view of the dual spring setup. These are the same 1 inch 550 thousandths diameter springs that AFR sent with the heads, and they are held in place with a set of chromoly steel retainers. And once everything is in place, Broker torques the nuts on the head studs to 100 foot-pounds in 3 stages. The intake manifold is going to be one of Holley's high ram intakes. Now you've seen these before on engine builds we've done with Prestige, and that's because these high rams just work. They move about as much air as you can get without going to a bucks down custom fabbed intake. This, obviously, is just the lower half. To make sure they get the absolute best flow into the engine, Prestige printed the Holley intake against the AFR cylinder heads to see exactly how they matched up. And then the intake got sent to LJ McCleary in the porting room to dial in the runners perfectly to the intake ports on the cylinder head. Now, if you'd like to learn more about how to print the cylinder head port shape onto your intake flange in order to be able to grind perfect port matches, I'll have more details coming up as part of a 460 cubic inch Ford small block build I recently had the opportunity to document with Prestige Motorsports. I'll have that one up soon, and I'll post a link to that video in the description below as soon as it's ready. So if this video isn't brand new anymore, it's probably down there now. Regardless, while McCleary was putting the final details on the intake runners, Broker installed the Scorpion rocker arms on the heads. These are Scorpion's Endurance Series aluminum rockers in the stock 1.6:1 rocker ratio. They connect to the BAM lifters with a set of 5/16 inch diameter, 80 thousandths wall thickness hardened push rods. With the lobe lift I already mentioned, that'll make gross valve lift be 690 thousandths for the intake valves and 688 for the exhausts. A light skim coat of ultra gray silicone helps ensure the intake gaskets won't leak. And then Broker lays a thicker bead across the china rails. Using ultra gray is important here because it's formulated to be both resistant to high intensity vibrations as well as decomposition if it comes into contact with fuel. And now the lower half of the Holley high ram intake can go on for the final time and be bolted down. Check out how well the runner and the cylinder head's intake port match up now. Like I mentioned earlier, the focus of this build is a healthy shot of nitrous to help us break the 1,000 horsepower barrier. We'll also be using modern fuel injection instead of the usual carbureted setup. So Broker installs the Holley billet fuel rails along with large 80 pound per hour fuel injectors from Excel. That's a lot larger than you're going to need in a naturally aspirated setup, but we'll actually be using the extra capacity of these injectors to take the place of the usual fuel circuit and solenoid to keep up with the nitrous. Just a few years ago, a setup like this would have been impossible, but now it actually makes using nitrous easier than ever. One issue many typically have when running a tunnel ram intake such as this is you have to completely pull the intake to install or remove a distributor. But thankfully, that isn't the case with the high ram. After pulling the cap, the Holley dual sync distributor drops right in. Then the cap can be reinstalled and all the plug wires hooked up. By the way, these plug wires are a set of Excel's relatively new Extreme 9000 wires with ceramic boots. You can't melt one of these boots on a hot header pipe even if you tried. And here we finally have the plenum top in place. As you can see, Prestige will be using a dual quad intake style. We'll be installing two giant 4150 flange throttle bodies up top, but not before adding a way to get a ton of nitrous into all 8 combustion chambers. To get copious amounts of nitrous into the engine, we'll be using a big shot setup from Nitrous Oxide system, or at least parts of it. The major components are the 2 square bore injector plates that will mount up between the throttle bodies and the intake manifold. They're designed to spray both nitrous and fuel, but we'll be plumbing up just the nitrous and plugging off the fuel port. Why? Well, just hang on, we're getting there. Anyhow, both injector plates utilize a single spray bar, but each one is drilled with 88 holes for a very even spray pattern. Holley says the kit is good for 190 to 300 horsepower, but we've got 2 of these bad boys, so the sky is the limit. And like a pair of cherries on top of our mechanical ice cream sundae go 2 of Holley's 1000 CFM 4-barrel throttle bodies. These utilize a 4150 flange, so they'll bolt up anywhere a square bore carb is designed to fit. Plus, they have integrated TPS, IAC, and air temp sensors to give an engine control unit all the information it needs. Finally, Broker hooks up a single nitrous solenoid which will feed both plates. Usually, you need to hook up a separate fuel circuit and solenoid to add fuel along with the nitrous, or else you're going to burn the engine down. And if you wanted to add lots of nitrous, you had to add multiple nitrous and fuel circuits so that you could bring the nitrous in incrementally and not all at one big hit and blow the tires right off the car. But we're attempting to do it all without any of that complexity. And with that, we're ready to move this show to the dyno. Prestige's Doug Aiken finishes up the nitrous plumbing. Here, he's hooking up the feed line as well as a purge valve. It's not exactly the most sophisticated setup, but for the dyno, it's all we'll need. Engine management will be handled by a Holley Terminator X ECU. That's for both the standard engine controls as well as the nitrous system. And that's what's really cool about this setup. By using large 80 pound per hour injectors, we'll depend on the Terminator X to add the appropriate amount of fuel all on its own whenever we make a nitrous hit. Nitrous doesn't make power on its own. Instead, it's a way to quickly and easily add more oxygen by injecting it directly into the engine. There, the nitrogen and oxygen atoms in the nitrous oxide separate, making the oxygen atoms available to burn additional fuel. So, if you don't add extra fuel along with the nitrous, the engine immediately goes way too lean, which is going to lead to expensive engine damage. In our case, we're ditching the extra fuel circuits and instead will allow the Terminator X ECU to sense the additional oxygen from the nitrous being injected into the system and pump extra fuel into the chambers to even things back out. It does this with the extra capacity of the 80-pound injectors we've installed, and it does it so quickly that the engine doesn't even have a chance to go lean. The Holley software for the Terminator X ECU is surprisingly easy to learn and use. Although you can input your own fuel and timing tables if you want, the ECU is self-learning and can handle most jobs itself. However, you can modify just about everything using the tables and option boxes in the software. For example, the Terminator X can actually pulse the nitrous jets to electronically control just how much nitrous the engine receives. And you can control it with this simple table. Here, you can see the progressive control is set to pulse at 50% up to 5,500 RPM, and then it ramps up to 100% at 5667. At this point, we're just testing options, and it won't actually use this tune. We'll show you a better setup in just a moment. But first, it's time to get a baseline. After a break-in period and a little tuning, we're ready to make a naturally aspirated run to see what this Ford can do before we add the nitrous. Now this is a very healthy engine. Even if we stopped right here and never cracked open a nitrous bottle, this is a performer. Prestige pulled from 4,000 RPM through 7,200, and the torque never dropped below 450 foot-pounds. Plus, it also had a peak of 631.7 horsepower at 6,900 RPM. Now that's pretty awesome, but it doesn't stop there. This is just the daily driver edition of this Windsor. Now, let's uncork the weekend party edition. We installed number 73 nitrous jets in both of the plates. The guys at Prestige calculated the two combined were way larger than necessary to hit our 1,000 horsepower goal, but that's okay. All the tuning will be done through the Terminator X ECU. And here's the table we used in the Terminator X software to control the nitrous progression. This is the setup we wound up with after a little tuning. Remember, you don't want to simply blast the engine with a 400 shot because there's no way you'd be able to maintain traction. So, as you can see, we have the nitrous kicking in at 5,000 RPM at 25% and then ramping up to 75% at 6,000 RPM. Then, we're holding it there at 75% for the rest of the pull. Normally, tuning has to be done by swapping out the jets for both the nitrous and the fuel solenoids and hoping that you get the mixtures right so you don't burn your engine down. But with the Terminator X handling the nitrous, air, and fuel mixtures, that simply wasn't a concern here. Honestly, it's incredible how much easier modern engine controls like the Terminator X make nitrous tuning. So let's bust open a bottle and let her rip. Look closely through the throat of the lower throttle body and you can see the nitrous kick on and fog the engine through the plate. Here's our horsepower peak. At just 75% flow, Prestige hit 1,001.2 horsepower at 6,600 RPM. Torque also jumped up to 898.6 at 5,600 RPM. That means we saw improvements of 369.5 horsepower and 376.7 foot-pounds of torque. Looking at the chart, you can see how the torque and horsepower lines overlap almost exactly up until 4,900 RPM. But after that, you can see the power ramp up as the Terminator X brings in the nitrous progressively. But there's a weird artifact in the graph that's worth noting. Check out how both the power and the torque lines are rising sharply and then dip right at 5,600 RPM. I believe this is actually an issue with the dyno's absorber trying to keep up with the power as the nitrous ramps up. We saw it vary as we dialed in different ramp rates, but the dyno absorber, and now that's the component that controls the engine's RPM and acceleration rate, appears to get behind when the nitrous hits and then overcompensates as it tries to catch up. That's the reason for the dip that goes away by 6,200 RPM. Overall, the results of this build on the dyno were fantastic. Without nitrous, this 427 cubic inch Ford Windsor produced 631.7 horsepower. That's more than 99% of the cars on the road, and you should still be able to daily drive it for years. But then add in the nitrous and you've got an absolute beast. We stopped at 1,000 horsepower just because that was Prestige's goal. But this engine is by no means tapped out. We were at just 75% of the number 73 jet. If you want even more power, just dial it up. You know, there's nothing new with nitrous oxide. This stuff has been around for decades. What's new here is the EFI and modern engine controls that makes nitrous tuning as simple as practically punching up just how much horsepower you want. Out on the street and no traction is limited, then slow the progression and lower the overall percentage. But if you're at the track and you know the surface is prepped and ready, hey, throw all the juice at it and get ready to embarrass your competition. It's as simple as that. Either way, there's no swapping jets or guessing at the tune involved. Just dial up what you want and enjoy the ride. Hey, thanks for watching.